Okay, so good morning everybody. As you see, it's not Henrik here today, it's Vuokko. So I will give the lesson to you today, and we'll dive deeper into, well, basic spatial analysis techniques using GeoPandas and Shapely. And those watching the video, I apologize, I might stand up sometime. Maybe before we start, what are kind of the most powerful feelings about exercise 2? Have you completed it already? No? Are you stuck somewhere? Yes? Okay. Okay. Some of you have completed exercise 2 already. Yes? Yes. Okay, so maybe if you want, we can then stay after the lesson and discuss about exercise 2 as well. And please voice your concerns in Slack, so the quickest one can reply. And please, I have Slack here open, so if you haven't joined all these channels, do it. People are asking useful questions there. You might find a solution, or you can then help others or ask questions there. Okay, so lesson 3, we have kind of 4 components. The first of them is geocoding, which basically means that we have addresses or place names which we want to turn into numerical coordinates using a function or some service. Or then vice versa, reverse geocoding would be the process of converting coordinates into place names or some other textual descriptions of locations, such as addresses. Then the 3 last sections will be about kind of spatial queries in a way. So far we have been asking questions from the data based on aspatial attributes, such as give me the rows that match this station name, or give me the data from between this and this date. So all of those have been queries, but based on these just regular attributes that are not related to locations. But here we will then ask questions related to the locations and the relationship of locations from different layers. So we have a point-in-polygon, an intersection, processes, then spatial joins, so we want to link data from one layer to the other. For example, give the name of an administrative area to the point that is within that area. And then finally, we'll introduce ourselves to nearest neighbor analysis. So from a set of points, what is the closest point to another location? For example, from all the hospitals in Helsinki, what is the closest one to you? In this case, through Euclidean distance, so we're not yet considering the road network in being just the kind of nearest points in space. So that's the content, and after this lesson you should be able to do geocoding in a programmatic way using the nominative interface from OpenStreetMap, and then conduct these different kinds of spatial queries and analysis steps. And then we have a few tiny tricks, for example, how to read KML files into GeoPandas. So you'll learn a bit more these little tricks and details related to different types of geographic data. Okay, so you should have all the updated materials in the web pages, Automating GIS. Course page 2018. Please let me know or post to Slack if you find some mistakes. There's always some of. Firstly, this is just a web page, a little explanation about geocoding. So I already asked if any of you have done geocoding. So some of you, at least the students from Kumpula, might remember from the basic GIS courses that we've had exercises of having a list of addresses of, let's say, kindergartens, and then you give those to ArcGIS, and then ArcGIS gives you a shapefile with the coordinates. So that's kind of the GIS example of it. But then, for example, in our everyday lives, we might use geocoding when we search for locations. If you come to Kumpula, you might do kind of a little geocoding step when searching for something. So for example, around Kumpula there's an address Väinöauerin katu 13, where I used to live a few years back. So what happens here is that I type a textual representation of the address, then in the background there is a geocoder that takes the address and based on some database or some calculations zooms the map into specific coordinates. And in this case it's Väinöauerin katu 13 because the house has a house number and it's located next to the Unisport. So this is an example of geocoding. And what we want to do, of course, if we have a bunch of addresses, say you have 100 addresses, you don't want to do it manually. We want to give it to some function and then as a return get a list of coordinates, so numerical coordinates. And then reverse geocoding would be the other way around, so in the background. And that's what happens. So then, in Python or in programming in general, we use a geocoder. So it's then kind of another package or another function that does the geocoding for us. And indeed, in Python and related to GeoPandas, we are often using the GeoPy library. Let's have a quick look at that. So GeoPy, well, wait. This is the page I wanted to show. Let's go from this GeoPy. Oops, not that. Sorry, demo effect. Well, I'll just show it from here. So basically, GeoPy wraps the services of different providers. For example, Google or Nominatim that I just showed, which works in the background of OpenStreetMap, Bing Maps, different types of geocoders that then have a bit specific way in which they work. So when we do the geocoding in Python, we can decide which service we want to use. So these are basically application programming interfaces. Have you talked about APIs or application programming interfaces yet? Or has some of you used APIs in any way? Okay. Well, basically it is kind of an interface between some service at the background, and then it provides some kind of inputs that we can send questions to, and then the API returns a result from some other service which we can't actually modify, but we can modify the questions that we give to the API. So then, for example, Google Geocoding API, we have used that in the course in 2016, but it then requires an API key, so we would have to have some kind of credentials. We need to sign up for the service in order to make questions to the API. And if you want, you can explore that on your own time and try to do geocoding using Google's geocoding API, which then of course works, for example, at the background of Google Maps. But in this exercise, we will use this OpenStreetMap Nominatim service because, well, it doesn't require us to sign up, but of course, that doesn't mean that we can do anything. So the service is rate limited, so there's only a certain amount of answers we can get from the API. So around one request per second, so we can geocode one address per second. And then if we would then, let's say, want to make a big application or do commercially these types of things, then of course we should then do it in a bit different way. But for the purposes of this course, where geocoding may be 30 to 40 addresses, it's totally fine to use the Nominatim interface. So indeed, that's what we are going to use, but it's good if you understand that it's only one of the many options. Okay, but then to the first programming part. So this is now a notebook that's available, so you can choose either to have the code ready there, as always. Then the student binder has the empty cells, so you can do the coding at the same time as I am doing. And then these notebooks should be available also in the CSC notebooks, so you can choose the one which you prefer. How do you actually often do you code while in the lecture? Yeah, so indeed, do say if I'm going too fast. Okay, so I selected the student binder for this lesson, and I actually have it loads. It shouldn't take too long, and when you open it, it should look something like this. And the first part of this lesson is indeed the geocoding in GeoPandas. So in GeoPandas, as Henrikki probably explained to you, so GeoPandas wraps a lot of functionalities from lower level packages. So for example, in GeoPandas, we can use the functionalities of GeoPy, the geocoding library. And that's done using a function called geocode. And so that we can practice this, we have some input data readily provided. So there is a folder called data. We could have a look at that. There's now something funny going on. Maybe I'll take this new instance. And there is just a regular text file called addresses.txt. It's a semicolon separated file. As you can see, there's an ID and addr standing for addresses. So the first column always has a running number as an unique identifier, and then there is an address of some location, even with the postal code number Helsinki, Finland. So for example, if there is Itämerenkatu in Oulu, I don't know if there is, but then with this information, of course, the search is limited to the specific area, and you won't get an address in Oulu, but in Helsinki. So that's the input data that we want to then, in a way, you could imagine that you want to add a column which has the geometry so that we can have it actually as a geodata frame in Pandas. So we will, first of all, of course, we'll need to read in the data, and that we'll do just as usual with Pandas, so we'll need to import. Let's do like import modules. So at least we'll need Pandas. So import Pandas as PD. And as I said, of course, then at some point we want the output to be a geodata frame. So for geodata frames, we need GeoPandas. So import GeoPandas as GPD. That's I think it is enough for now. Then, of course, if we want to read in the data, I think you've done this quite a few times, but repetition is always good. So we can define a variable FP standing for file path. And then, so the file was called addresses.txt. Then we might need to modify that still. So I am running this notebook in the lesson 3 folder. So this is my root folder, but the data file is located one folder down. So if I would now try to read this file path, it doesn't find it because it's trying to find it from this root folder. So we need to add that in relation to this file which I'm running, the text file is located in data and below that, correct? And then if you want to be safe, you can add the R letter in front in case you have some escape characters. For example, if you have -n, then it would break the file path. Okay. So then data, that will be our data frame for the input addresses, PD, read, CSV from the file path that is defined, and then the separator was semicolon. And then we can of course do data.head straight. So I guess this should be familiar. There was some weird okay, what's wrong? Sep. Okay, yeah. There was this morning some weird errors that came, but ignore them if the code works. I'll just check how. Okay, so we have the input data, and then we would want to geocode it. Of course, we don't yet know how actually in GeoPandas the geocoding functionalities are called, but we'll just kind of do it and then discuss a bit what it means. So in GeoPandas, actually, there is a kind of sub-package from GeoPandas. Oops, am I doing it in the wrong? Yes. So in order to do the geocoding, we need to import the geocoding tool in addition to importing GeoPandas. So from geopandas.tools import geocode. So if you would go about and Google this thing, geocoding in GeoPandas, how do I do this? Geocoding GeoPandas documentation. So you'll find a bit more information about this. So you could also call the tool like this, geopandas.tools.geocode, but here we do it so that we import it and then we can directly call this geocode tool. Is this clear to you? Yes. Okay. So now we have the geocode tool at use after running this cell, and then we want to geocode the addresses. So geocode addresses with the nominatim backend. So nominatim is the geocoder related to OpenStreetMap, as we discovered. And the output, so as an output, we'll have some kind of a data frame, which will be actually a geodata frame, and I'll call it geo. Then we'll call the geocode tool, and what does it take as a parameter? I don't know if this documentation is maybe not so extensive, but of course to the geocoder we want to give the addresses, and then we want to give a provider. So in this tutorial or in the documentation of GeoPandas geocoding, the provider is Google. And I think it is also that by default. So first of all, so we want to give the addresses and information about the provider. So we have the data frame, but if we actually, let's check, we had the data columns. What were our columns? So actually the address information is stored in the addr column. So we only want to give that to the geocoder, otherwise these might confuse or it probably wouldn't even work. So how do we access only the addresses? So this should be familiar syntax to you. So addr. If we pass a variable like this, then this is now a pandas series. So you remember the kind of intelligent list. So this actually contains then only the addresses with some index. I'll copy paste that. So we give that as the input parameter. Please geocode these addresses. And then provider is nominatim. So this would already work, but you then actually I'll run this, and then we'll check the warning that comes from there. And it might take a few minutes. So there is actually this is just a warning. It's not an error, but it's telling that please specify a custom user agent with nominative user agent my application. And this is because that then they can a bit track that who is using the API and how much you are using it. So now that we have 30 students using the API, they see some kind of activity in their service. So at this point, at least I think my geocoding worked. GeoHead. All right, or it's still doing it. Let's see. So if you think we had, how many lines of addresses we have? 34. So I believe that GeoPandas is kind of doing, it's giving this one, or we get the responses 1 per second. You remember it was rate limited, so it might take around 30 seconds or even more. Now it should be done to geocode the addresses. So I have an output, but let's first deal with this warning. So it's a lot of text, you can read it yourself, but indeed they are asking us to give a user agent parameter. So let's do that. Indeed, this warning didn't come before, but now they have added it. So user agent, and they want us to give a name of our application. We're not developing software here in particular, but we could, for example, each one of us could in a way have our own identifier. So we could, for example, tell that AutoGIS student, and then I put VH, which stands for my initials, Vuokko Heikinheimo. So you could put user agent equals AutoGIS student and your initials. So then there is some kind of a stamp about who is using this geocoding service. And if you run this, there shouldn't be any warnings. Then of course, if we would do something with more volume, then we need to have a bit better look at the terms of service, for example, of this provider. Did you succeed to geocode the addresses, or it ran without errors? Yes. Okay. So then you can of course check what you have. I think mine is still running. But anyway, as we asked, please geocode these addresses, and as a return, we got the coordinates kind of readily stored in a geodata frame. Let's wait for another 30 seconds. But if you have the results there already, you can have a closer look. Now there we have it. So there is column addresses, and then there is column geometry, and then of course I might want to check type geo. So this is actually a GeoPandas geodata frame. But if we now compare these addresses we have here, so for example the first one, Ruoholahti 14, Itämerenkatu, Ruoholahti, and then the original address, Itämerenkatu 14. So this is kind of then in the nominative database or in the nominative functionalities, the actual address where it has been matched. So these are not identical. So if we would now want to, for example, link the IDs of these original addresses to these, we can't do this kind of table join based on a common key because there is none. But anyway, this address column tells us the address that the geocoder found, and then from the original data you can see. So for example, this Bangkok 9 is some restaurant at index 2, so it was Kaivokatu 8. And then we have latitude, longitude coordinates, VGS 84 by default. Let's actually see if the geo.crs, if it's defined. Yes, so we have the EPSG 4326 is already in place there, so that's by default what the geocoder gives. Cool. So is there any questions about this? It seems quite easy, of course. Now here we have a nice example with a list of addresses that work, but then often if you do this, you'll have to a bit manually fix the input addresses. Of course, check that then it makes sense that they are in the correct places and such. So, for example, then to open the data in a GIS software or plot it, but we'll do that a bit later. So, as a final step of the geocoding, we would indeed want to join the geocoded output, which is this one, to the original data. So we have these, actually how many? Let's check, table join. Yes. So we have the data with 34 rows, and then we have the geocoded output with 34 rows. So all the data that we gave to the geocoder are in the output, but there is no common key. So before you've done this pandas merge, you remember, based on which exercise was it? There was a common key in one of these exercises. Was it then the ID or station name or some of these examples? But you can also do table joins based on indices. So we have we have always, when we join things, we have the left and then the right tables. And when you do the join based on a key, it doesn't actually matter in which order the rows are. But here, as we have the input and then the output, they are the same length, and actually they are in the same order. We can just kind of like glue them together in a way, and that's done in GeoPandas using the join function. Yeah, here is actually linked to the previous example of merge, if you want to refresh your memory about that. Okay, so we now are quite confident that we can join these. It's of course risky to join data like this if it's totally not, if the rows don't correspond, then you can join it, but the output will be nonsense. But in this case, we can do the join. So we'll call the output join, and then we will join. You can do it either way, but I'll explain why we do it this way. So as the left data frame will have the geocoded output dot join data, join head, and there we have it. First of all, why we do it in this order is that now we have something that is a geodata frame. I'm pretty sure if you do the join the other way around, you will end up with a pandas data frame, but we want to have the spatial data, so let's join the attributes from the spatial layer, the pandas data frame, to the spatial layer. So what we have in there is now the geocoded addresses, or the address related to the geocoded result, actually the numerical coordinates in the geometry column, then the original ID, and then kind of the original input address. So then of course this you could take into further inspection to check. So here was actually spaced. Let's leave this here. Type join. So we are now happy that it's a geodata frame. Sometimes, of course, if you do some data manipulation, yeah, question.
So
yeah.
When I geocoded the data, I got the columns the other way around. So I first got geometry, now I get address. Is there any reason why this happens?
I don't know. You probably did exactly the same way as
I just wanted to strengthen it.
User agent, data address, geometry address. I actually don't know if it's then random or and the input data is the same. So yeah, basically, well, it doesn't matter, but it's interesting if it does like that.
I have a question.
Yeah.
If the address and the text one of the addresses is missing or there's mistake in that, and then what will return? It will return none, or it will give a error.
You can test it. I don't actually remember now. It might also depend on the provider. Yeah, we should test that. I won't invent now responses, but in principle, let's say nominative is a bit more picky in terms of the input address, how it is formatted. So in Google, you can basically type anything. You can type in school, and you'll always get a response, even if it makes sense or not. So of course, one thing is to get a reply that is wrong, or then to get a kind of no data. But yeah, I don't remember by heart. I haven't done that in a while. But we could, for example, before the break test that. That's a good question. Yeah. Okay. We have the output. You might want to save it. Out FP, for example. We could save it again to the data folder to keep this folder clean in here. Addresses.shapefile will actually use this layer in the later part, so that's why we are saving it. Save to shapefile. Join to file out FP. Yes. So by default, indeed, GeoPandas writes Esri shapefiles. We all love shapefiles. So you should then see the bunch of shapefile related sidecar files in the data folder. And that's pretty much it. So there was the question about what if we wouldn't get a result? What happens? Of course. Well, do you want us to test it now? Enthusiasm. One is nodding. Yes. Let's test it. So let's modify. Of course, we would then have to know a case that doesn't work. But let's see. Well, let's first of all see, we'll just test this. I think this won't give us an error, but it might give us different results. Itämeren katu. So that's there. Saved this, Control S, then I would have to read it again. Okay, if you come up with an address that doesn't work, then we could have a deeper look at that. And indeed, there are cases even in Helsinki. If you have an address, it might end up there are long streets. And if you have like number 1 is here and number 2 is really like hundreds of meters away, so it might then calculate some imaginary houses in the middle of a park, for example, if it's not predefined. So be careful when doing geocoding. That's maybe all I want to say. Yeah, let's see still this output. But is there more questions about geocoding? You could of course then in GeoPy you can set the mode to reverse geocoding, so you will give points and then it will find kind of the nearest address or the most corresponding address to those things. But this you will need in the, for example, in the exercise this week. Moment. Let's check this geo.head. 92. Yeah, so now you see I changed the first line, so it gives a slightly different point, so it's just probably in the middle of the road. So that's how it works. If it gives you a reply even though if you haven't defined the street number. So that wasn't, we didn't yet manage to create a situation where it would give no coordinates. But then it gives a point, but of course that's just a calculation or an approximation. Okay, any more questions about geocoding, nominative? Then we'll move on to point-in-polygon. No? Okay. Okay. Next. So the next notebook is indeed point-in-polygon and intersect. Should look like this. Let's close that. Okay, so point-in-polygon intersect, as I told in the beginning, so now we'll start asking questions based on the spatial attributes of the datasets. Before, we've asked questions about the aspatial attributes, and we've used the pandas lock, for example, to position rows, and then these conditional statements within the lock function, for example, already in the first period. But here, it gets a bit more complicated. For example, if we ask, is this point within this polygon, or does this polygon contain this point, or what is the closest, out of all these points, what is the closest point to this specific point, such as in the case of hospitals close to your own house. So we'll first check a bit what's happening in Shapely before we go to GeoPandas. Here in Shapely, so I think you should have these codes ready so we don't have to spend time typing in some practice points. But we'll first see with just simple points, simple polygons, how Shapely answers questions such as, is the point inside the polygon, is it outside? And that's done with these, they are called these binary predicates, basically methods that give either true or false. So the response is a Boolean variable, true or false. So we have two kind of central functions or methods, and they are within and contain. So of course, if we ask the question in a way that is the point within the polygon, then we use the first one. And if we start from the polygon point of view, does the polygon contain the point, then we use contains. It doesn't make sense that a point would contain the polygon. Can be contained by, but that is within, in other words. So we have 2 points. Then we create a polygon into the memory. They are there. We can of course also, let's add this. So for example, check what the polygon looks like. I'm not sure. I think that might be the Senate Square of Helsinki, but you can check and plot it on the map. So we want to ask using Shapely, are these points within this polygon? So it is quite simple here. P1, we start from the kind of point perspective. Is it within the polygon? So that should be true. We could of course then next draw them in relationship to each other. Then P2, is it within the polygon? That should be false. So you could even by looking at the coordinates, is it now latitude, longitude coordinates, that it's actually smaller than any of these, so probably it is kind of on the south side of the polygon. But that's quite straightforward, and that is the function that we'll then later apply in GeoPandas. There. So then the first point was indeed within our polygon. So let's have another look at the coordinates of those. And then there is, I think you already learned this method during the first week, so there is this poly.centroid. So what is actually the center point? So they are quite, if we look at those coordinates, they are quite identical, so we might guess that the point 1 is actually pretty close to the center of the imaginary Senet square. Then the other way around, from the kind of polygon, starting from the polygon, does the polygon contain the first point? True. B2. And the second point, that's false. So it gives the same result, but it then depends on the kind of setting or the question setting, what you want to do. So here, for example, it's explained that if you have many points and one polygon, and you want to find out which one of them is inside the polygon, so then you'll need to iterate all the points and check, is it within, is it within, is it within, is it within. And then again, vice versa, if you have many polygons and one point, you might want to iterate, check all the polygons, if does this contain, does this contain, does this contain, does this contain. But you could of course do those also the other way around. So that's a very quick introduction to point-in-polygon, also abbreviated sometimes as PIP queries. Do you have any questions about these? We'll come back to this in the context of GeoPandas in a second. Okay, then intersect and touches basically. Maybe I kind of would want to draw this also. So we have, of course, well, maybe you can still see this. So we have one polygon here, and then we have a polygon that touches, and then we have a polygon that intersects. So in intersection, the key is that also kind of the insides of the polygons intersect. Of course, then we can have intersections between lines and polygons and such. But that's the difference between touches and intersects, and it might be relevant in some applications. But let's again generate some test data. You have these readily available. So we have line A and line B. They're quite simple geometries, and you might be able to answer the questions already by looking at the coordinates. But let's try what the computer says, or what Shapely gives us. So let's ask, does line A intersect line B? Zoop. Intersects. It does. Do they touch each other? So is there a touch relationship between these lines? Line A touches line B. That is also true. And then there's a little trick. We will do a bit more advanced plotting at the second half of the class, but one trick if you want to plot. So if I do now line A and press play, it plots the first line. Maybe I'll actually do them here. Line A is there, and then line, oops. You don't have to do this if you are confused, but I'll just put these in here. So we have line B, looks like that. So then if we want to just kind of on the fly plot those together, we can create a multi-line using the multi-line string constructor. And it takes as an input a list of lines we want to create the multi-line string from, and then print that multi-line. So they kind of have a joint node at is it then at this point and at that point. So if we look at the coordinates, it's this 1, 1, 1, 1. Okay, question.
So does intersect also contain touches in this case?
Yes. They intersect and touch, but then all intersections are not also touching.
Is that right? If it intersection then always touch?
Sorry? No.
Or touch is a subcategory of intersect?
That's how I understand it, yes. No, sorry, which way around? So if it's like this, they touch and they intersect. If it's like this, they intersect. We can check that, but that's my understanding of it. Okay. So then, in this second part of this example, we are asking if the line line A touches itself. So that would be false. But line A touches. Oops. But it does, so if you have two things on top of each other, exactly the same nodes, they do intersect, but they don't touch. So yes, in a way it's not. So if you touch, you have to have two objects that have a common point, but then continue to different ways without the intersecting interiors in a way.
Exactly one common point.
At least one common point. But indeed, as they are defined here, object intersects the boundary and interior of an object needs to intersect in any way with those of the other. And if an object touches the other one, it is only necessary to have at least a single point of the boundaries in common, but their interiors should not intersect. So those definitions you have here. But then how to do this all in GeoPandas? So we geocoded the addresses. I hope you have them. If you save them somewhere else, you need to modify the file path over there. But let's read those address points in a geodata frame. There is again this weird NumPy error, but let's ignore that. It shouldn't affect our working. So now comes a little kind of sidetrack about reading different types of files. So at the end, we want to ask questions about these addresses in relation to administrative area polygons, which have been provided to us as a KML file. Are you familiar with KML files? For example, in Google Earth. So it's kind of a data format that it can be a bit more complex. It can have these kind of sub-layers. It could even contain videos or such. So it's not enabled in GeoPandas by default. Basically, all the GeoPandas in and out functionalities are based on Fiona package. So Fiona is what happens in the background. And then, for example, if we look at the GeoPandas read file documentation, in here, so this is familiar to you, gpd.read file name, you could give a bounding box, and then there is this KWARGs, so keyword arguments. And it's explained here that keyword arguments to be passed to the open blah 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 method in the Fiona library. So in the read file GeoPandas, you can also have additional arguments which are then passed on to Fiona that's working in the background. And that's what we want to do now if we want to read the KML file. So there is this kind of module or component in Fiona, which is called supported drivers. We could have a quick look at that. So driver support in Fiona. So there's a list of all kinds of drivers. So these drivers enable the reading and writing of different data formats such as CSV, the geodatabase files, SRIS shapefile, GeoJSON, and so forth. But then, for example, there is KML somewhere. It's possible to do it, but it's not enabled by default. And through GeoPandas, we don't have to. We could also import Fiona, but we can call after importing GeoPandas, we can then call GPD in and out, file-related settings, Fiona, driver support, supported drivers to print out kind of the default data formats that we can read. So this is actually what defines what you can read and what you can't read with GeoPandas. So there is GeoPackage, the familiar shapefile, and so on, but there is no KML files in here. And then there is a little trick we're gonna do. Just gonna type it in and see what it does. So we're gonna I'll actually copy paste all of this so that we can access the list of supported drivers or the driver support list. So you can also copy paste that. Then it's practically a dictionary. So we will set that KML will be read and write. So we set that please read and write KML files, and then that's something Fiona can do. So indeed you can copy paste it from there. And then we could do another copy paste, check again the supported drivers. KML, so now under Idrisi you should see KML, read and write, and now we're able to read and write KML files. This is just something you need to know how these settings are configured. Any questions? Yeah.
So why is it not enabled by default?
I don't know. I guess it's not such a common thing to do, and maybe also because it's not the most simplest data file format. But yeah, I don't know if it then hurts to have it there by default. Yeah.
What does the A stand for?
Sorry?
What does the A stand for? R is read, W is write, and A?
That's a good question. I would think that it's raw.
Oh,
Yeah. But yeah, we can check that. Yeah. Okay. Well, I'll put these questions on the list of questions to provide better answers to. Okay. But that's it. So if we hadn't done that, we wouldn't be able to read the KML file, which it was readily provided in the data folder. So PKS Suuralue, it's a dataset downloaded from the Helsinki Region InfoShare for your information. And what it contains, it's polygons with these kind of Suuralue administrative area polygons. Okay, a number of rows is printed in there. There's 23 of them. So as a simple kind of point-in-polygon example, we want to know out of those geocoded addresses how many of them are actually within the eteläinen suurpiiri, which is the kind of southern district in Helsinki. So first we'll do again this kind of a spatial query. So we'll have some kind of a variable or data frame called southern equals we read the KML file into a variable called polis. So from that file please locate those rows which meet the condition. So we want to find all the rows, so there will be only one row, which is then the eteläinen. So we want to have polish, it was column name equals then eteläinen. You can also copy paste it from there, I think. That's it. And then let's check southern head. What do we, well, we can just print the whole thing because there should be only one row. What's wrong? Key error name. Capital N. Okay, so in the southern variable, it's a data frame, geodata frame with one row, description is empty, and then there's a polygon. Tiny detail, the Z here means that there is some kind of elevation information also, or could be stored in this type of polygon object, which came from the KML file. Okay, so we have that. Maybe there is now the index 10 that we inherited from the original data file. So you might have done this trick before, but we can kind of reset the index that we have index 0 in the eteläinen, so we don't get confused with the number 10 at some point. So southern reset index drop true. So this drop true does it that it doesn't store the old index, it just forgets about it. And then you can do this in place true, which means that's kind of in place, it replaces the contents of this data frame, so you don't have to do that southern equals reset index drop true. You can do in place true. I think you've done this before already. Okay, and then we can print it again after doing that. There we go. So then we have a nice clean kind of reference polygon to do the point-in-polygon query with.
Could you explain the in place again, please?
Okay. In place, so you might have done, we could do this also like this. So we would have southern equals southern reset index drop true. Because if we do only this, it only kind of prints the output but doesn't store the results anywhere. So we can either store the results in a variable called southern like this, or then we can tell that do this process and do it in place, so replace the values in the current data frame.
Which is in place, right?
In a way, yes. So it does it to the current, because if I do this, it just kind of does it, but the result is not stored anywhere. So either we have to in place, do the procedure and replace the values in place, or then we do this. Maybe a bit, yeah, okay. Okay, this is supposed to be a markdown cell. Okay, so let's finally plot something to speed up a bit. So I guess last week you did some simple plottings of geodata frames, and it's indeed quite easy, but for that we'll need now, because we want to plot in a way in the same figure, we would want to see the districts and then the points. So we'll want to use matplotlib for that, and you'll see soon why. Lib py.pyplot as plt. Did I type it correctly? Matplotlib.pyplot as plt, so the familiar module from the first period. And then first create a figure with a subplot. So we want a figure and we want one subplot so that we can refer to the same subplot and print kind of the spatial layers on top of each others. So this is again the same thing as from the GeoPython, plt.subplots. I know this is a bit confusing syntax to some of you, but what happens in there that this plt.subplots returns kind of the figure element and then as many subplots as you defined, and here we only get one subplot out of there. And after we've done that, plot the polygons. So we have the administrative area polygons we want to plot. We can do polys plot, and we want to set that the subplot is the one subplot we have. And then there's a parameter face color, which kind of colors the interior of the polygon. We will then have a separate lesson of kind of plotting maps with Python, but this is now the simple plotting. So I'll give you some time to type it in. We could no matplot. What did I type wrong? Matplotlib dot pylplot pyplot. I might have to do this. Okay, so with this syntax we can just plot the KML file that we read in. Any questions so far? Yes.
If it's not working, what was we need the magic command?
If it's not working, try to type in this plt plot tight underscore layout, and then there was this map, something inline, something. It does not work for you?
The picture doesn't come.
Yeah. Huh? Sorry.
Inline. What was the inline command?
I don't remember it by heart. Yeah. It might be like percentage matplotlib inline, but you might want to Google it. I don't remember. If you're working on your own computer, right? Yeah. Yeah. Okay. So we have the base layer, the polygons. Then we have the southern, and again, now this is the key that we do again to the same subplot. Please plot this selected thing, and as we're working with spatial layers, the one that we plot the first is the bottommost. Then we plot stuff on top of each other, so you can construct a simple map like this. So then face color is, let's say, red, and we can again check how this turns out. What happened? I have some serious typing errors this morning, but it's good to do mistakes sometimes. So now we can see which is actually the southern district that we selected. And it's plotted in red on top of the gray layer. Then finally, plot points. We have the points in a geodata frame called data dot plot. Again, the same subplot. Color, you can use another color, but I'll put blue. And then there's a parameter marker size 5 we can use to plot the points. So this is a good habit if you're doing some modification selections. Just plot it quickly. Ugly map doesn't matter. Just to check that, for example, the projection is correct and such. Okay, then let's move on. I'm a bit slow, but let's see how far we get. So there's yet another trick. There is this thing in Shapely that I don't know, in exercise 2, was it very slow for you to iterate over the rows and calculate things? So there I think we had some 8,000 points, right? 80,000 points, yes, thanks. So of course we could discuss that tomorrow in the practicals, but there are also quicker ways to solve that problem. But also in Shapely you can kind of speed the process up by enabling speedups. And how I understood this is that then it enables code that has been written in the language C, which is much faster than Python. So that's one trick we can do. So of course, if we have millions of rows and we do things row by row, and each process would last a second, then you can calculate how long that would take. So we'll just run this. It's a good trick to remember. You can of course test actually how much it speeds up the process. Okay, but finally, we want to ask the question that which of these blue points, so which of our address points are within this southern district? Very simple example, but works for our purposes. So basically, we start from the point of view of the points here. So is the point within the polygon? Point within polygon. So we have the data. And in GeoPandas, you can actually call the shapely within like this, and then it will actually apply the within command for each row, kind of under the hood. So it will go through the data frame row by row and check if each point is then within whatever we put inside there. And then, of course, what is our polygon? It's the southern. But here you have to then give the actual shapely polygon, which we can access from. We had the index 0 as we just fixed the index, and then the column geometry. So southern lock geometry, what is that? It's basically the polygon, so the target polygon, and then when we call this data within polygon, so then GeoPandas does the within shapely process for each row. That's quite logical. So let's see what we get out from this. So as you remember, these shapely within contains, they were these kind of binary functions. So it will return true or false. Is it within? Is it not within? True, false. So print pip mask. So as an output from this query, we have for each row in the input data, we had 34 rows in there. So true, 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 false, true, false, false, false. So there's maybe like 1, 2, 3, 4, 5, 6, 7, 8, 9-ish points that are within the polygon based on that. So we kind of get this Boolean mask. This is a Pandas series again, the intelligent list with information, is this row inside the polygon in question. Then to go one step further, we can then apply that mask. This is now a bit the same stuff that the NumPy guys are doing. So data lock, please locate all those rows where this pip mask is true. So then we'll actually retrieve only the rows where the within the spatial query was true. And let's print the whole thing. So indeed there is 1, 2, 3, 4, 5, 6, 7, 9, 8. Did I calculate correctly? But these points are then within the selected polygon. And then of course we might want to see that on a map. I will just go ahead and copy paste all of this. You can do that as well. And then let's modify this a bit so we can plot again all the districts, southern district, then the pip data, and we could put it as golden and plot that. This was a bit quick, but I'm pretty sure you all can copy paste. So indeed, in the pip data, we have only the points that are within the polygon. So now we can do quite powerful things already with GeoPandas. Great. Any questions? No questions. So let's have a break. Let's try to be back in 15 minutes. So 5:25 to 11. I think we're gonna make it in time, hopefully. for the rest of the stuff. So what we have left is then making spatial joins, so then actually bringing the attributes from one layer to another based on spatial location, and then the nearest neighbor analysis, which might be a bit challenging, but you'll practice it also in the exercise. So see you in 15 minutes.